Good day everyone, my name is Puganeshwaran Analaki Krishnan. Me and my group members will be presenting our group assignment for this particular tablet, which is Lajak Array H. Here I present our group members' name, Kuma, Lo Huyun, Nurul Husna, Mohammad Haidar, Mohammad Firdaus. So today we'll be presenting, so let's begin. So for the introduction, I would like to introduce you guys where Lajak Array tablet is a health supplement diet produced by Lajak Laku company. So they are like producing 15 different types of Lajak Array tablets, and for each tablet there's a data sheet containing 200 sample observation drawn at random from 3 daily manufacturing shifts uh, at the morning, evening and night. So for our group, we are assigned to analyze still Lajak Array H. So let's go to part A. Here's the part A. Part A asking us to describe and summarize the sample data of your assigned Lajalaku tablet produced in December 2021. Present your observation effectively in numerical, tabular, and graphical form. So before we assign everything, here I would like to literally uh, make a pie chart based on our daily shift, like how many shifts are there for each particular data. So here are the frequencies, like for the morning shift, as you've seen at the blue color here it's a 70, and evening shift 70 as well, night shift is 60. So altogether it's 200. Next, here for this particular part A, here are the most likely called mind map or something, is to where we have to summarize the data, and then we have to accumulate the data in a graphical form, numerical form, or tabular form. So these are, you can see like there's 4 set of tables here. Here are our summarized data, and as we analyze based on the given data sheet to Earth. So from the set of data given, there are 200 samples of larger Curie fields taken from 3 different production shifts, that is morning, evening, and night shift. So for the first table, it contains sum, mean, mode, median, range, minimum, maximum value, variance, standard deviation for each weight, each factor with their weight, relative density, and tensile strength. So as you can see here, it's already summarized based on the data given to us, which are for the particular tablet larger Curie H. So as you see the second table, it represents the weight range on the left hand side and the frequency on the right hand side. So for the weight range, we have divided based on its interval, which is for each particular interval in between there are 10. As you can see, the highest frequency is at 343 until 353. As grand total is 200 as given to us. So the second table is related to relative density range and frequency. So you can see the maximum frequency lies between 87.3 to 88.3 for the grand total of 200. Next, we go to tensile strength range. As you see, the maximum frequency obtained is 44, which is at 7.1 to 7.2 uh, range at a grand total of 20. So these are the tabular forms that we accumulated from the given uh, data sheet to us. Next, let's go to the graphical form. So as we see, these are the graphical form which is in the term of bar chart. Bar chart, as you see, between the range of 343 to 353 for the weight range, the frequency is 54, which is the highest at that particular point for this particular data, which is Ajak hit. Next, for the tensile strength, the highest range is 44. The highest frequency is 44, sorry. So it lies between the range of 7.1 to 7.2 as been seen here. For the particular data larger Curie H. Second, as we see the relative density here, the highest relative density obtained is 45 for this particular data that larger Curie H.
Assalamualaikum, my name is Nuruzna and I am in charge of Part B. In Part B, the question asks us to provide the evidence that the weights of the tablet does not follow normal distribution with a mean of 350 milligrams and standard deviation of 14 milligrams. So in this part, we are going to use the goodness of fit test since the question asks whether our data follow certain distribution. The first step of the goodness of fit test is we determine the hypothesis. Since H0 will always be equal, so our H0 is X is normally distributed. Meanwhile, the H1 is X is not normally distributed. Second step is test statistics. We conduct the table to find out the chi-square test of the data. And lastly, step 3 and 4, the rejection region and conclusion. Using the alpha of 5% and nu of 2, we found out that the chi-square is 5.9915. It shows us that our chi-square test is within our exception region. So the conclusion is we have no evidence to reject H0, so we accept H0 since the chi-square test is within the exception region.
Now we are going to discuss the part C. It is to present the required analysis and comment on whether there is any significant difference between table weights from the different sheet. For this question, we need to do the analysis of variance ANOVA. ANOVA is also a statistical analysis to test the degree of difference between two or more groups of an experiment. So we use the 0.05 label of significance for this question. Step 1, hypothesis statement. We state the H0 equal to mu1 equal to mu2 equal to mu3, and H1 equal to mu I is not equal to uj. For at least one pair of ij, the step 2 is test statistic by using the SU. Here is the output from the SU. We know that we have 3 different shifts, morning, evening, and night. The total count for each shift is 70, 70, and 60 respectively. And the summation and average and variance is also auto-counted as well. From here, SS is sum of square, and DF is degree of freedom, and S is mean square, and F is F stats, and F critical. Then we go to rejection reason. From here we know the F critical is 3.042 and F test is 0.72 at 0. F test is not fall into this reason. So we made the conclusion, since F test is less than F critical, then we accept the H0. No, there is not any significant difference between table weights from different sheets at 5% significant level.
Saidar. Today I will be presenting about the first part of part D from the project. In this part, we were asked to find the tensile strength of the tablets that has low relative density value, which is 68%, 74.3%, and 80.1% using the linear regression method. For step 1, we need to determine the dependent and independent variables. The dependent variables, or y, is the tensile strength, and independent variable x is the relative density, based on the table that was provided in the Excel before. Then step 2 is insert the data into the Excel and then choose regression analysis and line fit plots. Then it will display the summary output with the scatter diagram. Here's the tables that was produced by the linear regression method. And then this one is the graph. The orange dot indicate the predicted y variables. By drawing a straight line from bottom to upper part, we get the fitted regression line equation, which is y equals to 0.0767x plus 0.53552, and this equation will be used to find our answer later.
Okay, now let's take a look on the result. To find the value of tensile strength for each relative density, we can just use the fitted regression line equation as shown on the right side there. For example, when we substitute 68% into the x variable, we will get 5.5708 megapascal. For 74.3%, we will get 6.0540 megapascal. And lastly, for 80.1%, we will get 6.4989 megapascal. So from the result, we can conclude that the prediction for three low relative density value of 68%, 74.3%, and also 80.1% is invalid as they are not within the given range, which is 82.8% as the minimum and 94.2% as the maximum value of the data. On top of that, based on the summary output table, the value of Pearson product moment correlation coefficient, or simply known as correlation coefficient, R, is 0.8171140002. Therefore, by looking at the value of the R, which is close to unity, and the scatter diagram plotted, we can observe that the tensile strength and the relative density of the tablet are having a strong positive linearity relationship, since the scatter of the point around the best fitted linear regression line is close to the fitted line. So I think that's all from us. Thank you.